Almaciga resin is used in the manufacture of varnishes, lacquer, soap, paint, printing inks, linoleum, shoe polish, floor wax, plastic, waterproofing materials, paper sizing and many other products. Locally, it is used as incense in religious ceremonies, as fuel, torches, caulking substances and smudge for mosquitoes. The Almaciga tree, scientifically known as Agathis philippinensis, is a large, coniferous tree native to the Philippines. It is known for its valuable resin, which is used in varnish and other products. The Almaciga is categorized as vulnerable due to threats like illegal logging and unsustainable resin harvesting practices. Key characteristics of the Almaciga tree: size. It can grow up to 65 meters tall with a trunk diameter of up to 3 meters. Resin. The tree produces a resin that flows from its bark when cut. Timber. It is also a valuable source of timber. Distribution. Found in mountainous forests across the Philippines, including Quezon, Zambales, Palawan, and others. Cone structure. Produces both male and female cones, with male cones being cylindrical and female cones resembling a globe. Conservation status. Categorized as vulnerable due to threats from illegal logging, unsustainable resin harvesting, and land use changes. Importance of the Almaciga tree. Economic. Resin collection provides income for indigenous communities and other forest-dependent populations. Ecological. Almaciga trees play a vital role in forest ecosystems and contribute to carbon sequestration. Cultural. In some areas, Almaciga resin is used in traditional practices. Conservation efforts. Projects and studies are underway to ensure the sustainable management and reforestation of Almaciga trees. These efforts aim to address the threats to the species and support the communities that rely on it. Sustainable resin harvesting techniques are being explored to minimize harm to the trees. Almaciga trees in the Philippines produce a valuable resin known as Manila copal, which is a key ingredient in lacquer and other products. This resin is also used in varnishes, paints, printing inks, and more. The Almaciga tree is an important non-timber forest product, providing sustainable income for some indigenous communities. Resin used in the manufacture of varnish. Varnish, liquid coating material containing a resin that dries to a hard transparent film. Most varnishes are a blend of resin, drying oil, dryer, and volatile solvent. When varnish dries, its solvent portion evaporates, and the remaining constituents oxidize or polymerize to form a durable transparent film. Varnish is primarily used as a transparent protective and decorative finish for various surfaces, especially wood. It enhances the appearance of the underlying material while also providing a barrier against damage and wear. Lacquer. Lacquer is a type of hard and usually shiny coating or finish applied to materials such as wood or metal. It is most often made from resin extracted from trees and waxes and has been in use since antiquity. Lacquer is very different from a varnish finish. Firstly, it is solvent-based, usually made with shellac and alcohol. As the solvent evaporates, it leaves behind a hardy layer on surfaces. Lacquer comes in a wider variety of shades than varnish finishes and dries much quicker. Soap. Resins can be incorporated into soap making, often for their potential antibacterial properties and ability to add a unique fragrance. Different types of resins, such as pine resin or frankincense resin, can be used, sometimes in the form of infused oils. However, it's crucial to be aware of potential safety considerations, especially during the mixing and curing stages of resin, as some resins can be toxic if inhaled or ingested. Here's a more detailed look. Resins in soap making. Resins, like those found in trees, can be incorporated into soap recipes for their potential benefits. Examples. Some makers use frankincense resin, often infused into an oil first, for its aromatic qualities. Benefits. Some resins are thought to have natural antibacterial properties and can add unique scents to the soap. Safety considerations. It's important to note that some resins can be toxic, especially during the mixing and curing stages. Always follow safety guidelines when working with resin. Toxicity. Resins may release harmful fumes if inhaled or ingested, and prolonged skin contact can cause irritation. Disposal. Proper disposal of resin is also important to avoid environmental harm. Infusion. Some soap makers create resin infusions by steeping resins in carrier oils, like olive oil, to extract their beneficial properties and scent. Copal resin example. Copal resin, for example, can change the viscosity of the carrier oil. Grinding. Resin can be ground before infusing it into oil. If using a grinder, be aware of the potential for small particles, although these are generally considered safe in small amounts when making soap, according to a Reddit thread. Mixing with soap. While some sources suggest that mixing soap directly into resin can affect the resin structure, you can create inlaid designs by using soap within a resin mold and then rinsing out the soap later. Resin soap typically includes a combination of fats or oils, and alkali like lye and resin. Common ingredients can include coconut oil, olive oil, shea butter, and sometimes specific resins like pine resin or frankincense resin. Other possible ingredients include distilled water, sodium hydroxide, lye, and potentially fragrances or colorants. Here's a more detailed breakdown. Fats and oils. Coconut oil contributes to lather and hardness. Olive oil provides a mild and moisturizing soap. Shea butter adds moisturizing and conditioning properties. Other oils. Sunflower oil, sweet almond oil, castor oil, and palm oil are also common. Resins. Frankincense resin, known for its aromatic properties and potential skin benefits. Alkali. Sodium hydroxide, lye, is the most common alkali used in soap making to saponify the fats and oils. Water. Used as a solvent for the lye and to facilitate the saponification process. Additives. Fragrances, colorants, and other ingredients can be added to customize the soap. Resin soaps, like those with frankincense, may also be formulated with specific ingredients to target mature skin, potentially including pink kale and clay. Paint. Resins are a crucial component of paint, acting as the binder that holds all other ingredients together and provides adhesion to the painted surface. Different types of resins, such as alkyd, epoxy, acrylic, and polyurethane, are used in paint formulations to impart specific properties like durability, gloss, and resistance to weathering. Here's a more detailed look at resins in paints. What resins do. Bind the paint together. Resins act as the adhesive, holding pigments, fillers, and other additives in a stable, cohesive mixture. Provide adhesion. Resins ensure the paint adheres firmly to the substrate, the surface being painted. Contribute to film formation. When paint dries, the resin forms a continuous film that protects the surface and holds the pigment in place. Determine key properties. The type of resin used significantly impacts the paint's durability, gloss, flexibility, and resistance to various environmental factors. Types of resins used in paints. Alkyd resins, known for their durability, good weathering properties, and low cost, making them suitable for many synthetic paints. Epoxy resins offer excellent adhesion, chemical resistance, and high durability, often used in industrial coatings and primers. Acrylic resins, versatile, providing a good balance of hardness, flexibility, and durability, widely used in waterborne paints. Polyurethane resins, known for their toughness, abrasion resistance, and resistance to chemicals and weathering. Phenolic resins can enhance the durability and heat resistance of paint when used with other resins like alkyd or acrylic. Vinyl and acrylic emulsion resins, essential in emulsion paints, providing adhesion, durability, and overall performance. Resin painting. Resin painting, often using epoxy resin, is a technique where resin is mixed with pigments or other mediums to create art design. The resin can be layered and shaped as it hardens, allowing artists to create depth and unique forms in their pieces. Resin provides a glossy, protective finish and enhances the vibrancy of colors in the art design. Printing inks. Printing inks primarily consist of pigments, vehicles or binders, and additives. Pigments provide color and opacity, while vehicles bind the ink together into the substrate. Additives modify the ink's properties, such as drying time and flow. Here's a more detailed breakdown. 1. Pigments. These are the colorants, either organic or inorganic, that give ink its hue and opacity. Organic pigments. Derived from carbon-based compounds, offering a wide range of vibrant colors. Inorganic pigments. Made from minerals or metals, known for their lightfastness and stability. 2. Vehicles binders. These components hold the ink together and help it adhere to the printing surface. Resins. Form the backbone of the ink, influencing properties like adhesion, gloss, and durability. Oils. Can be vegetable-based, like linseed or soybean oil, or petroleum-based, acting as solvents and affecting drying time. Varnish. Often made with vegetable oil, it increases the glossiness of the printed material. 3. Solvents. These are used to make the ink flow smoothly and can be water-based, solvent-based, or specialty solvents. Water-based solvents. Examples include ethylene glycol and its derivatives, often used in environmentally friendly inks. Solvent-based solvents can include alcohols, ethanol, isopropyl alcohol esters, and ketones. Specialty solvents, used in specific printing processes due to their properties, like fast volatility. 4. Additives. These are various chemicals added to modify specific properties of the ink. Drying agents. Accelerate the drying process. Waxes. Improve rub resistance and gloss. Lubricants. Reduce friction and improve flow. Anti-static agents. Reduce static buildup. Thickeners. Adjust viscosity. Defoamers. Prevent foam formation. Dispersants. Wetting agents. Improve the dispersion of pigments and ink flow. The specific combination of these ingredients varies depending on the printing process, e.g., offset, inkjet, flexography, and the desired properties of the final print. Linoleum. Linoleum is primarily made from natural ingredients: linseed oil from flax wood flour, rosin, ground cork dust, and calcium carbonate, all combined on a jute backing. Pigments are often added to achieve desired colors. Here's a more detailed breakdown. Linseed oil. The solidified form of linseed oil, called Linux-YN, is the key binding agent. Almaciga rosin. Solidified resin from Almaciga trees acts as a binder and adds to the material's flexibility. Wood flour. Finely ground wood adds to the durability and lightness of the linoleum. Cork dust. This ingredient contributes to the material's strength and flexibility. Calcium carbonate, a mineral filler, often derived from limestone, adds to the overall composition. Jute. This natural fiber forms the backing fabric that holds all the other ingredients together. Linoleum is known for its durability, anti-static properties, and its natural composition, making it a popular choice for various applications, including flooring.